Most surface texture parameters treat the profile or the surface in 3D as if it were one particular signal. Now, in many cases, that's not true. For example, this surface has a smooth zone in the middle with some peaks out of it and some valleys sticking out of it as well. And this is where the RK parameter family becomes useful. The RK parameter family is going to try to target these three areas: the middle, the core or the running surface, and then the peaks and the valleys around it. To do this, we're going to start with a material ratio curve. So if you haven't seen that video already, I would encourage you to go check that out. And then when you're done, come on back here and we will continue the exploration here. So the material ratio curve for this profile might look something like this, and we're going to have 0 to 100% material. The RK parameter family starts with determining this middle running surface, the surface that's going to do the bulk of the work after the peaks wear away. To find that middle part of the surface, we're going to look for the most horizontal region of the material ratio curve. And to do that, we're going to take a 40% wide window. This is 0 to 100, so if we take a 40% wide window and slide it back and forth, and look for the region that's the most horizontal. In that case, or in the case of this surface, maybe we'll find that around here. So that might be the most horizontal part of this curve. And when we have that, we're going to draw a line through that region from 0% all the way out to the 100% point. The end points of this line establish the RK value. So RK is a height. It's the height of the core, or kernel in some writing, for this surface. It's this height over here is RK. Now once we have this RK line, we actually do have a height position, and we can draw a line across that height, and everything above that would be peaks. So this area above the curve here would be the area of the peaks over here. Now that area is what we're going to use to calculate kind of an effective peak height. It's called a reduced peak height, and it's reduced because it's not the top of the highest peak, but it's going to be reduced to what we might call an effective or somewhat of an average peak height. We're going to take this blue area right here and make a triangle of the same area. And this triangle will have some height, and the height of the triangle may not be the height of the highest peak, but it is a measure of peak heights really based on area, and we call this RPK. Similarly, on the valley side of the curve, this line would drop down here, and this area is the area of the valleys below the RK region. This area is kind of a curved shape, so once again we'll use the top leg of that shape and create a triangle of equal shape. This triangle height, or in this case perhaps depth, is the RVK parameter. So the RK parameter family gives us a sense of the peak heights, the running surface of the core, and then the valley depths of a surface.